Now,
welcome to the open door. Jim Hanning here with fellow panelists Mario Ramos-Reyes and Valerie Niemeyer. Today, we explore the relation between faith and science. We'll do so from the perspective of philosophy, especially Thomism. Our welcome guest is Professor Paul Julienne. He is a groundbreaking quantum physics researcher, long affiliated with the Joint Quantum Institute at the University of Maryland. He was recently elected a member of the National Academy of Sciences for his exceptional original research. Julienne helped establish the science of ultra-cold matter, which investigates atoms and molecules near absolute zero. As always, we begin today in prayer. Come, Holy Spirit, fill the hearts of your faithful and kindle in them the fire of your love. Send forth your Spirit, and they shall be created, and you shall renew the face of the earth. O God, who have taught the hearts of the faithful by the light of the Holy Spirit, grant that in the same Spirit we may be truly wise and ever rejoice in his consolation. Through Christ our Lord. Amen.
Amen.
Let's start with some philosophy. As an Anglican, Paul, how did you come to be a Thomist?
Well, that's certainly an interesting question. It has several dimensions to it, some more recent, some a little bit older. So let me just start with the generality. The Anglican world has always appreciated philosophical reason. And of course, the fathers and councils of the early church, and there certainly have been and are Anglican Thomists, even contemporary ones. So, but going back many, many, many years ago, when I was in college, just studying to have a career in the sciences, I had to decide whether science and my Christian faith conflicted with one another. And in studying philosophy and taking philosophy class, I sort of more or less accidentally stumbled across St. Thomas and people like Gilles Son and Jacques Maritain, and some contemporary Thomists and at that time, and as well as other philosophers like the philosopher-scientist Michael Polanyi, who's not a Thomist, but certainly taught us how to do science non-reductively, and you don't have to be a materialist and reduce everything to matter and motion. And so between all that reading back in college, I really got from Thomas Aquinas a basic sound idea about how to not be a positivist in the scientist and not be a reductive, someone who just wants to reduce everything to matter and motion. So that goes way back. I mean, over the years, I've had a longstanding interest in healing a rift between science and religion that many people perceive, and so I've had developed classes on this over the years from an Anglican perspective, and there's a lot of prominent Anglicans working in the area of science and faith. Alistair McGrath at Oxford University is one example. Sir John Polkinghorne at Cambridge is another. And so there's a lot of prominent Anglicans working in the area of science and faith. More recently, my daughter was taking classes at the John Paul Institute down here in Washington, D.C., and the John Paul II Institute on Marriage and the Family. And she told me about a book being released and a talk being given by Professor Michael Hanby down at the Institute called No God, No Science, which touches on the issues of science and theology, in particular from the standpoint of St. Thomas and the whole Christian philosophical tradition. So I went down and heard Michael's talk and introduced myself to him. We had lunch. I wound up later taking some classes from Michael at the Institute and from some of the other philosophers looking into the Western philosophical tradition. So I got to read from classical sources myself, some of the church fathers and Aristotle and Thomas Aquinas, as well as other contemporary Thomists, including Anglican Thomists. Good Anglican Thomist is Simon Oliver at the University of Durham, who's a good friend of Michael Hanby and even gave a talk at the John Paul II Institute when I was doing classes there. So basically and I just discovered St. Thomas has what we need philosophically to bring a sound understanding of why science is possible and what science is actually accomplishing, I think. So, and Thomas is for all Christians. He's for the Eastern Orthodox and the Protestants and the Catholics all together, and for everybody else, actually, because to the extent that his philosophy points us to the truth about reality, anyone who respects truth should appreciate St. Thomas. So I hope that's kind of a short but maybe long-winded answer.
No, it's just great. One little postscript. At our last meeting of the American Maritime Association, an Anglican, Travis Dumsday, gave a paper on Eric Maskell, who was very much a Thomist and an Anglican.
That's true. Yes, I have his book, The Openness of Being. It's his Gifford lectures.
That'd be good for the open door.
Yeah, probably.
All right. Well, Mario, you want to pose another question?
Well, it's very interesting. I never thought about this relationship between Anglicanism and Thomism that way. But I heard you, Paul, talking about science all the time. And you want to somehow reconcile both the philosophical tradition and science, or Christianity and science. And I agree with that, but I have I'm not saying different view, but when you talk about science, you talk as if science is just one way of thinking, which is a model, and a model shaped by empirical science. When you come from the Hispanic tradition, I'm talking about Spain, the long tradition, Thomistic tradition of Spain. When we talk about science, we qualify very specifically that we are talking about empirical science, social sciences, even philosophical sciences, theology is a science. So we are very careful in saying, what science are we talking about? And so given that background, what do you understand by knowledge itself? Is science, as you said, in the Anglo-Saxon tradition, based on a specific model of reasoning?
Well, that covers quite a bit of territory right there. Of course, the Latin word for science, which is scientia, gives us our word for science. That's the Latin word for knowledge, actually. And St. Thomas talks about science and divine science and so forth. So the word over centuries has had many, many uses. Peter Harrison is an author from Australia who used to teach at Oxford, this professor of science and religion at Oxford University in England, wrote a book about how science has changed in its meaning over the last 2 millennia. So it's very worthwhile. But knowledge has many dimensions, from a focal knowledge to very specific things to an overall grasp of the whole. Human knowledge covers everything from knowledge of trees and stones to knowledge of one another, to other human beings, knowledge of how stars generate their energy or make light. It just covers everything. And the human mind really has a vast capacity for all of this. So knowledge covers a lot. Aristotle opens his opening line of metaphysics is, all human beings by nature desire to know. So human beings, we learn from that, both have natures and they have desires. And one of those desires is to know. Now, the Greek word here is not the Greek word so much for science, episteme. It's the word that really means more than just head knowledge. It means a grasp of things. It means understanding. Things come to light for us. We come to see what things are. So that knowledge is a very deep knowledge. So knowledge has a long history in the Western philosophical tradition. So, and one of the things that Albert Einstein said that is most profound and beautiful, he wrote in an essay in German in 1936 in the Journal of the Franklin Institute, interestingly enough, an American journal. He said the eternally incomprehensible thing about the world is that it is comprehensible. That is to say, it's knowable, it's graspable by our minds. And Einstein used that wonderful German word, ein Wunder, which means a miracle in German. It's a miracle that we can do this. So interestingly, comprehensibility and incomprehensibility both go together. So in a certain sense, all being is an intelligible mystery, both knowable, comprehensible, but yet also a mystery. So knowledge also is something that we never do alone. We always do it together. In a certain sense, let me say it a little differently than Descartes said, I think, therefore I am. I prefer to say, I know because we know. There's an old African proverb, I am because we are. There's something larger than any one of us, and we're part of something larger. Knowledge only makes sense within a much larger whole. So there's a world out there to know, and that broader world, of course, includes God, I would affirm. And so knowledge is based upon something that transcends us, that is beyond us, and we need to respond to reality as it presents itself to us in some way. And we do that together in a community. So as a scientist, I have to go to school and learn from others. I have to learn from teachers. I have to learn from the textbooks. I have to learn to a whole body of knowledge that's built up, and I have to make it my own by doing the homework, by engaging with it and thinking about it, doing it. So knowledge involves a vast scope from all of reality, the whole of things, to communities that engage with the production of knowledge of certain types, and to the individual who knows knowledge. All knowledge ultimately is personal knowledge, as Michael Polanyi says. It's my knowledge and known to my mind, or as Aquinas would say, to my intellect, which means more than the modern term intellect. Thomas would also call this the intellectual soul is what knows. But we have this capacity. And of course, to Thomas, that comes to us from our senses. We take it in. There's something in our mind that sheds light on what we take in to extract from what we take in from the world. Its form, its meaning, its intelligibility, its comprehensibility. And through the concepts we form, we return to the thing and know the thing that we see, take in from the world. This is very, very different, by the way, than modern philosophy teaches us, which tells us what we know of the things in our head. We know our concepts. We know what's inside our head. No, to Thomas Aquinas, our concepts are the very things that our mind pulls out of the sensible images, and through which and by which we come to know the thing which is outside. So we really know the thing that's outside through the things that we take in. So this is about how knowledge happens. I think that the way Thomas sees that is much better, I think, than many modern people schooled in John Locke and Immanuel Kant see things. So Jacques Maritain said there's a nuptial relationship between mind and being. We're really made to know things, to grasp their truth in our loving embrace, as it were. So now we get to truth. I mean, scientists are realists. I mean, we really do think we're learning something about the truth about the world. But in order to understand the truth of the world, I think we have to understand what is the world. And there's this larger reality, which includes the reality of God. And how do we put it all together? For Thomas Aquinas, the truth is a kind of conformity between something out there in the world and a mind. Without mind, there is no truth. But truth, like goodness, also reflect a certain, quote, transcendental property of being, something characteristic of all beings. In particular, it's a kind of relation. It's a mode by which mind relates to things. And as St. Thomas tells us, we have to look at the whole of truth in defining the truth of a thing. When you talk about scientific truth, what are we finding? Well, modern scientists may have one understanding of that, but I'm trying to get at a metaphysical or a deeper philosophical understanding of what is truth. What are we really doing? And so it'll help us to understand better what science is doing as it knows things. So what Thomas, behind all of his notion, all of his philosophy, is this notion of creation. There's only two kinds of being in the world. There's the internal, uncreated being of God, and there's the created being of changeable and things that are in flux and things that are like us. We're created beings. So all things that thus are sandwiched between two minds or two intellects, the intellect of God, the mind of God, and the human mind, which comprehends things. We're the ones who do science here in this world. And Thomas quotes a remarkable statement from Aristotle, about truth. And I think this actually touches back upon Einstein's point. So Thomas says, and he's particularly here thinking about the human being, he says there must be a being that can agree with all things in order for there to be truth. And that being is the soul, the intellectual soul, he says, quoting from Aristotle, which, quote, is in some way all things, unquote. In some way, our intellectual souls have access to all of being, all of reality. It's remarkable. It's that things are comprehensible across a vast scope of things. It's absolutely remarkable. However, the conformity of mind and being, there's two aspects to that. There's the mind of God who knows things, and there's the mind of the human being that knows things. So the measure of the truth of all things, to Thomas Aquinas, he rather explicitly say it, comes from God. It's God's creative knowing, creative thinking of things that makes them to be and gives them their being. And it's the conformity of the mind of God with the thing that gives things its truth. From the human side of thing, what Thomas says is our minds don't measure things, rather things which are given their being by God and reflect his truth, things measure our minds. The only thing our minds can measure are human artifacts, things we make, the works of our own hands. We know what we're doing, and as it were, we can, but yet if there's something out there in the world, we have to conform to its truth given to it by God. So created things are real and have the natures that they have precisely because they're creatively thought by God. That's the source of the intelligibility of being, and why things are understandable to us, why we can do science. Interesting, atheist, the atheist Jean-Paul Sartre, the existentialist philosopher said, human beings and other things can't have any natures for one very good reason, he said. There's no God to think them. If there's no God to think them, things can't have natures. So why do we have this beautiful order in the universe? It's because God thinks them creatively. That's what Thomas Aquinas would say. I think that's a very important thing to know, but there's another very, very important corollary to this. Thomas is very clear, we can't know the divine essence. The whole patristic tradition of Christianity tells us God in his essence of who he is, we can know that God is and that he creates, and we can know a lot about him, but we can't know his essence as he is in himself. And therefore, the way in which God creatively thinks things, as it were, coming out of his essence, is sealed off from us forever. It's part of the apophatic dimension of knowing. There are things about things that are made, things about created things, is so rich that they're being creatively thought by God. They have being. There's so much positivity and richness to their being. Things are bathed in the divine light, as it were, and that makes them both intelligible to us but unfathomable to us, because there are things about God. God is intimately present to things, and we can't really fully know them. So we know God from creatures. We also know creatures, as it were, by analogy with other creatures. So in a certain sense, we name atomic being, the kind of things that I work with, from ordinary things in the world, but we can't really know atomic being fully. When we get to the root of the world, the root of things, the root of matter and what it's like, there's a mystery there that's fundamentally impenetrable. So I may not be talking like most scientists, but I think I'm talking like a scientist when I say that. So we truly know things, and we know them positively and know what they are, but yet there's some kind of this dimension of never knowing things fully. You know, quantum physics, scientists still argue over the meaning of quantum physics. It is so strange. The being of the atomic world is so different from the ordinary everyday being that we have no way of even articulating what it's like. Yet, as Thomas said, we name God from creatures. We also name atoms from creatures. So we have to be apophatic downward towards the things at the atomic world, just like we have to be apophatically upward towards God.
Paul,
yes,
you were on the verge of pausing.
I was almost, and you probably say I've talked too long.
You were on the verge of pausing. And you told me in an email that you had so much to say on this question that Mario so innocently posed to you. You had so much to say on this that you probably would need some pacing. So my first reaction to all that you said is, wow. And my second reaction is, hot damn. And for something more probing, I'm going to ask Mario if he has maybe a question he'd like to ask, and then I'm going to turn things over to Valerie with a different sort of angle.
It was too rich to ask another question, but I don't know if my goal was for our audience that generally our audience are part of the American Solidarity Party.
Yeah,
And,
right. You had to bring that up, didn't you?
Right.
Okay, go ahead.
And so, and this is what happened a couple of weeks ago. Someone said to me, well, you know, politics is not a science. And I said, yes, it is. No, it's not. And I said, well, what is your argument? Well, it's not a model on chemistry, physics. It's just an art. It's a way by which you go, move again, and you just seize power or get elected, whatever. And I said, no, that's Maritain claim in 1942. That's Machiavellism. So that's my question. Many people, even those who are part of the Christian tradition, claim that politics is not a science. Why? Because in our mindset, science has a specific way of thinking, which is probably, I don't know, correct me if I'm wrong, is the model is a model on physics. And so when people talk about science and have in their mind this type of model, therefore those knowledge that are part of this are not scientific, that's art. So what, when you talk about science, which of those set of knowledge is really setting the model for a scientific knowledge? Is history or political science really science, or are just fake sciences?
That's a big question. Science, of course, as I said, historically would mean any kind of knowledge that starts with certain basic principles dealing with some basic subject, and you develop knowledge. Well, there's different ways of thinking about it, but in a certain sense, the sciences have come to the natural sciences have come to have a fairly particular meaning. People always fight over the meaning of words and who gets to control the meaning of words. So I think a lot of battles have to do with that. When knowledge, let's look at it this way. We're dealing with reality in some ways. So there's reality. Reality has many layers and different dimensions to it. There's all of reality in a sense. Metaphysics deals with being, the science of being qua being, as we'd say. The science of being is the science. Okay, well, anyway, that's what traditionalists would say. There are many kinds of sciences. There's chemistry and physics, of course, but to think that somehow chemistry and physics is so basic and tells us what everything is and how we can understand everything, ultimately reducing it to physics, is sheer nonsense. I mean, you can't reduce everything to physics. There are things that there's different dimensions. There's to reality. I mean, the human being is a political animal. We belong in a polis, in a city, and so, in a certain sense, there's an order to that. Science, in a certain sense, I suppose you could think of science in its greatest generality as trying to bring some sense of order and cohesion and understanding to being under certain aspects, say under the aspect of physical being, of matter in motion and things like that, or the fundamental atomic level of how things get built up. Chemistry goes a little deeper and deals with more complex entities, many atoms bound together in molecules, making chemicals and chemical reactions. And biology deals with cells and how cells build up organisms and how organisms live and develop and so forth. And then you go on from biology to more complex sciences, psychology, or maybe ecology, how different things, entities all fit together in a very complex ecosystem where everything is related to everything else. politics is a kind of complex human ecosystem. I mean, there's all kinds of ways you can think about things.
Okay, Paul and Mario, politics. Oh, politics. Now, you're looking at Valerie Niemeyer, and she's smiling because she's just back from round one of the American Solidarity Party's convention. Round two comes up this weekend, and Valerie was engaged in what? The science of the impossible. And she's weathered the storm, and I tell you, she has that smile on her face. But if she wants to add a postscript from the so-called real world of politics, that's fine. Or maybe she wants to push us ahead and see what else is looking for our exploration. Valerie, up, you're on mute. Oh, no, we can't have you on mute. No,
You're
no.
right.
All right.
With 6 kids upstairs, you never know
Oh, you
exactly
need
what
it.
sound might
You
be
need
making it into the room. So you said it. You said the word exploration, and I was thinking a lot about that as I was listening to you speak. Just this idea of this great frontier of discovery, and that the way that science is about discovery. And I was just wanting to actually know more. I don't really have much to say about the convention other than it was a journey of discovery for me. You know, there's a lot of, I think at one point somebody said politics is chaos. So I know that there's a science of chaos and I don't know, entropy, but then trying to make order out of disorder. I mean, all of that relates to politics.
Is biting your tongue a tactic?
I think so. And speaking is a tactic. But yeah, as far as your frontier, would you tell us a little bit more about what kind of science you do? What is your focus in this kind of journey of discovery?
Sure, I would love to. My area is fairly simple. My background is in chemistry and mathematics and physics, and my particular field, we call it AMO physics after its abbreviation. That stands for atomic, molecular, and optical, which deals with what it says: atoms, molecules that atoms build up, and with light in particular in all of its dimensions and different wavelengths and so forth and so on. So that deals with matter on its low energy, ordinary scale of things, not high energy, not nuclear physics, not biological physics and very complex things. Fairly basic physics dealing with the basic constituents of matter. The Joint Quantum Institute deals with atoms and molecules and light, particularly under their quantum mechanical aspects, which you have to deploy when you get to understand things at a fundamental level. So one of the things of course, many years I was not only at the University of Maryland, I was a part of the National Institute of Standards and Technology. So we, at the physics laboratory, so we are into the science of measurement, particularly doing things like making the most accurate atomic clocks in the world and that kind of stuff. But in order to measure atoms, we really make good clocks out of them. We find it's really good to slow them down and make them stop and hold them still. Don't let them move around. And so my colleagues at NIST have done a lot of work in getting the coldest matter in the universe, which is just a few billionths of a degree, maybe even less than a billionth of a degree above absolute zero, where atoms slow down. And we know from the Heisenberg uncertainty principle, if you slow things down, if your velocity gets very near zero, we pretty precisely have pinned down the velocity to close to zero. So we really can't know where they are. So they spread out all over the place, and they do some very fascinating quantum mechanical things, very intelligible things, as any, I think, grad student in this area would tell you, but yet very odd and strange. So my colleagues, two of my colleagues at NIST, Bill Phillips in Gaithersburg and Eric Cornell in our labs in Boulder, won the Nobel Prize in Physics in the 2 Nobel Prizes for their work in developing ultra-cold matter and making the coldest things in the universe, and for the interesting purposes like building better atomic clocks. But the whole field has exploded. So I'm a theorist. I both explain what these people do and try to predict new things for them to do that are really neat and interesting. So And one of the things I've learned to do is to work with individual atoms one by one at a time. You can make little arrays of 1, 2, 3, maybe up to several hundred atoms, place them exactly where you want to. Now, of course, the light exerts forces on atoms, so you can actually hold wave-like particles or atoms acting in a wave-like way in boxes made out of walls of light, which is kind of fascinating. It's called optical lattices, and some of my colleagues at NIST helped develop these things, or optical tweezers. We can pick up at one atom at a time and move it around, put it somewhere else, and that kind of thing. Atoms have interesting personalities too. I've got to know quite a few different atoms during the last few years: cesium and sodium and ytterbium and strontium, and fairly intimately. And they all have their unique personalities. It's really quite fun to get to know them. They are quite intelligible, but they're very mystery. If you think the Trinity and the Incarnation is a mystery, try working with atoms. I think they're probably more.
Well, you know, that I have a 16-year-old who would be fascinated by everything you're saying. I'm just sort of like glazed over, like, whoa. But one of the things you mentioned, light, and so back to the convention, one of the things that came to mind, because I think about light a lot, light and darkness. And one of the things that I quoted at one point during the convention was that there's a lyric from Rend Collective, a Northern Irish band. It's a praise song, and it says, "The dark is just a canvas for the brightness of your glory," speaking to God. And I often think about, you know, the light and the darkness, that we're called to be the light in the darkness, and that, you know, the American Solidarity Party is called to be the light in the darkness of our political and cultural times. So, and I, even with my kids, I think about when I read literature and stories, I think with them about, well, where's the darkness here, and where's the light, and this tension. And so I'm just going to throw that out there, because on a less technical level, I wonder if you ponder about that, you know, about how your work connects to these kind of the story elements of life. And you don't need to answer that right now, but I'm just going to throw that out there if at some point you do have something to say about it.
Light is an absolutely wonderful image, and it has been for a long time. Of course, there's that wonderful Plato's allegory of the cave about the creature living in the shadows who comes out into the dazzling brightness of the light of the sun. And of course, nobody believes him when he goes back and tells him what he saw. Light is indeed fascinating. You know, ordinary everyday light is, scientists would call it, it's chaotic. Light exists in all of its different possible states in a sort of a probabilistic, disorganized sort of way. But there is coherent light. Laser light is coherent, and it's very different, because all the photons, as it were, and they act as one, as they don't act individually, each photon doing its own thing, so to speak, moving in whichever direction it desires, independent of all the others. They act as one. And so laser light focused is extremely powerful and much more intense. I mean, you can do a lot with that, I think. One of the fascinating things that one of my colleagues did, and he got his Nobel Prize for, some Einstein and an Indian physicist by the name of Bose predicted back in 1924 that if you can take a certain kind of particle known as, we now call them bosons, but it could be a lithium atom or a sodium atom or a cesium atom, and you can do the right thing to them and get them cold enough, they make something that we now call a Bose-Einstein condensate. That's the matter analog of a laser, of coherent matter. All of the atoms, as it were, are absolutely doing the same thing, so to speak. They're all lined up. You know, and I think of what Jesus said, that his prayer for his disciples is that they all might be one, so that Father, that the world might know that you have sent your Son. So when we're one, when we're coherent, but yet individual, but yet have that coherence, I think there's some powerful analogies you can get out of science that you can build upon, of light and all of its properties. So everything we know about the heavens comes to us from light of various kinds: microwave, infrared, visible light, X-rays, ultraviolet, gamma rays. It's
Philosophy is light of reason.
Yes, yes.
Thought.
Yes, I make one other point about light. Thomas Aquinas uses that image of light in that, that fundamental act by which things become intelligible to our mind. We have two kinds of intellects, as it were. Thomas speaks of our active or agent intellect and our passive or patient intellect. So we have both a receptive passive aspect and an active part. And that active part in us, by which what comes from the senses is rendered intelligible, he speaks of it as a light. The active intellect shines a light on the sensible image and enables the mind to extract what it is, so we know the universal from the individual. And Thomas, that's a case philosophical use of that term light. There's a light within us, as it were. That's one of the most profound mysteries of all reality. The twin mysteries to reality: the mystery of being, why is there anything at all? And the mystery of the intelligibility of being, why is it comprehensible? We have a light in our minds, as it were, that lightens up the world for us. And that is a certain way in which we participate in the wonderful creation that God's given us.
All right. Are you ready for a pivot?
Yes, sure.
I want to bring us back from the light of this and the light of that to summer school 2023. One of my granddaughters is beginning summer school for high school with a strategic course, preparatory algebra. Now, the fact of the matter is, and you know this to be true, Paul, she could be joined by 95% of the people in the United States of America. We suffer from innumeracy. We don't know diddly squat about mathematics. And yet you, in unguarded moments, have acknowledged that mathematics is the language of science. So how is it, Paul, how is it that 95% of the population of the United States of America is going to follow what you're doing when we are mathematically, to be delicate, mathematically fragile?
That's fascinating. By the way, my first love of mathematics was stimulated back in high school when I discovered geometry in Euclid.
Plato's Academy had a sign over it saying, let no man enter here. Two conditions: you have to be 30 and you have to have had geometry.
Yes. Geometry makes wonderful. Have any of you ever read Edward Abbott's wonderful little book, Flatland?
Heard of it.
It's a wonderful book. A Hollywood movie was made out of it, actually, and they actually use it in high schools to teach certain aspects of mathematics. Absolutely magnificent little book. Anyway, it's about a two-dimensional world that is inhabited by circles and squares and two-dimensional beings. And but yet one of them has a revelation. He has a visitation from a sphere from the third dimension, and he can't understand it. He's in this room, and this little point appears, and it gradually becomes a circle and becomes bigger, as of course the sphere passes through the room and the plane cuts the sphere. So it just blows his mind. And of course, no one will believe this sphere thing, so he gets rejected. And ultimately, it's all a story about how the little square gets vindicated and everything. But it takes us into a new dimension and gives us some interesting analogies to think about geometrically, which lots of people can think about geometry fairly easily. It doesn't have to be differential equations and integral calculus. However, scientists do have a responsibility to educate other people, non-scientists, about the sciences, whether it's every man in the street or the churchgoer in the pew or the advanced theologian or the monk or even other scientists in other fields. So, and how do we do that? We have to build models and give people the public models or analogies, pictures that help us understand, stimulate our imaginations. Maybe we can't, there's a lot of popular books about the sciences that don't go into mathematics, but do try to give the picture. We have to translate the mathematics into words and pictures. But if you do that translation, you're not writing prose, you're writing poetry. And it's not fiction, but it's not really hard fact either. It's illumination, it's understanding. I mean, we need to teach people about the humanity of the sciences, that scientists are human beings too. You know, there's a lot of biographies of scientists that tell something about their lives and what they do. If you want a fascinating biography, read about Michael Faraday and James Clerk Maxwell, the inventors of the electromagnetic theory of light. You could not get two people more different than Michael Faraday and James Clerk Maxwell, both Christians, by the way. Fascinating story. There's some wonderful book about that. I think the book is called Einstein's Heroes because Einstein drew upon both of them. They were really radicals, anti-Newtonians for their day. You know, Maxwell gave us a theory of radio waves and electromagnetic radiation by which people learned how to send signals across great distances using radio signals and things like that. Late 19th century. Fascinating discovery. You don't have to do a lot of math. What Maxwell did, he put the mathematics to the fundamental intuitive picture that Faraday had. Faraday knew that if you took iron filings and you shook them on a piece of paper and put a magnet beneath it, they organized themselves into field lines around their little lines, circles around the poles of the magnet. You've probably seen these things yourself. That's a visual picture. You can go explain that in vast, complicated differential equations in mathematics. But Faraday intuitively knew there was something going on. There's a magnetic field going through space. And the Newtonians in physics of the 19th century couldn't believe this. How in the world can you have this force, magnetic force penetrating through space in a field? Now nobody has any trouble talking about magnetic fields. Magnetic field is a model. It's a concept that explains very complicated mathematics. So scientists need to develop these pictures and tell it to us. So scientific illiteracy is a problem, so we need better science writing. I hope to write myself. I have written some about, and you can find some of this stuff on my website. But yeah, we need to do more writing. I need to do more writing. My daughter says we need a book called Metaphysics for Children. We also need to teach everybody basic philosophy so they understand how to think about the world and not get taken in by all the reductive nonsense of materialistic science and the atheistic science that occurs in so much popular science writing. Science doesn't have to be written atheistically. I'd love to write about science for children from the standpoint of Thomas Aquinas. I think it'd really be neat.
And there's 6 of them upstairs at Valerie's house. Mario, you're next.
Well, what you are saying is so interesting. I have the experience. Let me explain a little bit of the context. I have the experience of meeting and knowing Dr. Dennis Quinn, who was the creator of the Integrated Humanities program at KU many years ago. It's a long history.
K is for Kansas, Mario. K is for Kansas, right?
Right.
I thought so.
Well, the approach that he and Dr. Senior did in this program was what is called, they call poetic knowledge. Now, poetic knowledge doesn't mean learning poems or stories. It's about knowing reality, and the spark that we need to somehow awaken people is wonder. And so from that, everything follow natural sciences, any knowledge. And so that our society is so lack this kind of wonderment because technology, that we need to educate people in this long tradition that, as you said, begin with Plato and the Greeks and somehow got killed at the beginning of modernity with Descartes and all these philosophers. So I think that's very interesting. So the beginning of science is philosophy as such. Now, having said that, I have a personal curiosity, given your wisdom in science, and I'm gonna ask you something that you may not want to answer, but what do you think about artificial intelligence, which is everywhere now?
It's interesting. A colleague of mine many years ago used to have a little placard over his computer that said, "No amount of artificial intelligence can ever overcome natural stupidity." It's artificial. It's a very interesting question. I suppose I am among that minority of scientists who think that artificial intelligence is not the same thing as human intelligence. There's something in the human being and the human mind, the human soul, that will never be captured algorithmically or by a artificial programmed kind of entity. That is to say, no robot will ever quite be like a human being. But it's a fascinating area, and it's an area about which I'm not an expert, but I think there's an awful lot of things that were artificial things that we make can simulate things that it may look like intelligence, but ultimately, will it be? Will it have understanding? I don't want to go into the Turing test or the Chinese room test from philosophy right here. It'd take too long to explain that, but I'm not sure if we can actually build a machine that will pass the test fully.
Thank you.
All right, Valerie.
I wonder if this is related at all, but what's the difference between efficient and final causation? And is there any place for final causation in science? And by the way, you've been speaking, I assume yes, but
yes, there is. In fact, that's it gets us into the notion of a cause, and that could take us down a lot of rabbit trails, but cause basically accounts for what's happening. So Aristotle, I think, here actually had it right there. 4 kinds of causes. And Thomas, of course, adds a secondary and primary cause for the primary and secondary causation to another kind of cause. But the 4 causes of Aristotle are the formal, final, efficient, and material causes. So there's water boiling in the pot on the stove, okay? And we want to know why, okay? Well, the simple answer is the formal and final cause. I want a cup of tea. Well, science likes to use the material and efficient cause. Material cause is the water in the pot on the stove. It's the material stuff involved. The efficient cause is the application of the heat, which causes the water it's the force, as it were, that's applied to the water that makes it boil. So that's the material and efficient cause. But that doesn't go far enough for us. It doesn't really explain why the water's boiling at all. I mean, okay, heat's being applied to it. Sure, that's the material. But it's the formal and final causes that are the most important, because they really give us the meaning of what's happening. Why is the water boiling? I want a cup of tea. The formal cause is the cup of tea. That's the what it is that's being produced, the what, the form of the thing. And the final cause is to satisfy some end or goal, my desire to drink tea. Maybe I want to quench my thirst, maybe just like tea. So in order for something to be intelligible, to make sense to us, we need all 4 causes, So in a sense, what happened in early modernity is formal and final causes kind of got shaved off by Occam's very sharp razor, Occam's razor, who says, you don't use things you don't need. And he thought you didn't need to know about form and finality and stuff like that to really understand things. So it started getting shaved off then, let's say. In early modern science was content simply to look at matter and mass and velocity and speed and motion and the forces that move things around. So the cosmos came to be seen as a machine. But to my mind, that was really a mistake. We really made a big, major mistake, both scientifically and philosophically, in shaving all form and finality of the world, because form and finality makes things intelligible. I mean, I think it makes quantum physics intelligible. Things have order to do very definite things. What about the laws of nature? They manifest form and finality. An electron next to a proton making a hydrogen atom kind of knows what it's supposed to do. It obeys the laws of nature. It conforms to them. How does it know to do that? Well, this is part of the mystery of the world. But the equations give to the world, they're in mathematical language, they're representation of what I think the classical philosophers would call form. a mathematical representation of the formal being of the world. That matter conform, all matter, physicists have no trouble saying there's no such thing as just brute matter. All matter is already and always dressed by form. It's informed, it has form. The hydrogen atom and all hydrogen atoms are the same thing. The electron knows what to do around the proton. And it has a purpose, it has an end. So hydrogen can bond with other atoms and like carbon atoms and other things and build up molecules, and molecules can build up cells and organisms. Ultimately, that builds up us, but we don't reduce us to that building up by the matter but there's an end to things, that we can be here as the kind of beings we are to participate in the world as it is, imaging God and being in his image and likeness. So the world has the form it has and the atomic being it has, so we can participate in it as we are. There's finality written all over everything, and people are absolutely blind and can't seem to see it. But that's part of matter itself, in a certain sense, is unintelligible. And for two reasons. I mean, we need this wider scope of even the smallest atom is situated in a reality where it gets its being from the transcendent being of God. And
Paul,
to see that wider picture, we don't see things fully.
Paul, we only have 10 minutes left.
Okay.
I've got to pace you. So I want to get back to this cup of tea.
Good.
And I'm looking for some explanation here. And I want to begin with a scientific explanation, but you threw an Aristotelian curveball at me. Now here's a cup of English breakfast tea, and you see who's on the mug here.
Yes, I see a curmudgeonly cup. Yes.
G.K. Chesterton. Now, if I ask this question, or somebody asks the question of me, why is it that you're drinking this tea, or why did you boil the tea, or what made the tea work? I might start in with an explanation, if I'm of a reductivist mind, in terms of material and efficient causation. But you say, aha, that's not enough. Why did you want the tea? Well, you wanted the tea because of such and such, and then you shift the discussion from the tea to me. But suppose somebody wants to do a scientific explanation of my wanting the tea. They might play the material and efficient causation cards again. And there I am, up in a puff of scientific smoke. I was going to introduce teleology, but they say, never mind, we can put that on the back burner. What we want to do now is have a scientific explanation of your wanting the tea. And they come up with some material and efficient explanatory mechanisms. And you say what? You say what? You say, what was that question after all?
Yes, well, teleology, I basically asked the question, okay, you're a scientist, atheist scientist comes, why do you want to know these things? Why is science possible? Why can we even do science in the first place? Why do you want to know things? What's going on here? If it's all reducible to these forces and there's not something more going on in the world, isn't there more? Isn't there something? There's something that transcends these simpler explanations that without it, there's no meaning. And the atheists are right. If there's no God to creatively think things, there is no meaning. Eat, drink, and be happy. I mean, so the question is, though, we have this deep sense within us that there's meaning behind things, there's intelligibility, and we want to know, we have this desire to know there's something going on in reality that is not explained, is not adequately explained for, because science can't give us, all scientists say we can't get meaning from science, but meaning is very important. Most of the great scientists will say meaning is important. They'll say we get it from philosophy or something beyond science or metaphysics. Science can't give us everything according to the way it's practiced. All the scientists will tell you. Richard Dawkins will tell you that the important things in the world, something science can't tell us why they're important.
So that the idea is, if someone gives a materialistic, reductive account of why I want tea in the first place, the response is, well, that hasn't really explained it.
It really hasn't explained anything. Now, I would like to say something, though, about causes that I think is very important, and that's Thomas's understanding of primary and secondary causation, that God is different. He infinitely transcends the world. He has a mode of causation of the things in the world that we will call his primary mode of causation, by which everything comes to be and is upheld in its being. This is what we know as creation by God. But things in the world are given their own proper agency, their own proper operation. It's called, Thomas calls this their secondary causality. I had a little passage I wanted to read it. So I'm just going to read this little passage from Sum of 1:105. So speaking of God, Thomas says, and he's referring to the book of Job here. He's going to come down to it. So Thomas says, therefore, he, God, is the cause of action, not only by giving the form, which is the principle of action, but also by preserving the forms and powers of things. Because in all things, God himself is properly the cause of universal being, which is innermost in all things. It follows that in all things, God works intimately. For this reason, in Holy Scripture, the operations of nature are attributed to God as operating in nature, according to Job 10:11, quoting from Job. Thou hast clothed me with skin and flesh. Thou hast put me together with bone and sinews. So what are we to make of this? Are we to say nature had nothing to do with Job, his conception from his parents and the development by normal biochemistry and assimilation of nutrients into his cells to grow up to make his bones in his body? Are we going to discount that and say it doesn't happen? Well, of course not. Thomas says those are secondary causes. Those are the operations, the proper powers and operations that things have, that have been given to things as their own proper agency. They're their own. They do things on their own. They have their own powers. But the primary cause of everything and the upholding of these powers is from God by his primary mode of causation. And that's the mode of causation we have no access to. We don't know how God does it because we don't know the essence of God. So God's primary causation is active in absolutely everything. Job is fully made by God and clothed by God.
All right, now we've got, believe it or not, less than 5 minutes left. And I'm going to have a pop quiz. And it would be polite to ask our guest to have a pop quiz, but why not pick on Valerie? Valerie, in 5 or 6 minutes or so, your kids are going to ask you, all 6 of them, what was that all about? Your answer is, and let's see what the teacher says about your answer. Paul will be the teacher. Your kids are popping the quiz on you. They're going to ask you, what was that all about? And you're going to say,
No pressure here. Again, how do we discover? How do we discover and understand and relate with reality as God made it and as we can understand it in order to live as closely with him as possible?
I think you aced it. Paul, what would you say?
Let me go back to fundamental basic principle. Reality is intelligible mystery. It has the dimension of intelligibility and comprehensibility, and we do that through our sciences. All of our sciences, including political and historical ones and metaphysical ones, as well as the natural sciences. But reality is also mystery. And if we have to have the humility of intellect and humility of spirit in approaching things. And basically, the bottom line of things, for Christians, it's very simple. There are 2 great commandments: know and love God and neighbor. It's a lifelong endeavor that can never be fully exhausted. That's the bottom line, as it were. Science is part of that, of course. We know about the world through the sciences. And I think it's important that theologians understand the sciences. And theology, it's appropriate, actually, for theology can critique the sciences too. I mean, philosophy can critique the sciences and say, sciences, stand up. This reductive materialism stuff you're doing is nonsense. You got to grow up and not do that anymore. And we can show them, give them, explain to them better ways of doing that.
And we know also, Paul, that science relies on experimentation.
It does, yes.
And
that's true.
Valerie is going to bring to real politics this weekend the test of intelligibility, discerning the relationship, the proportion between that which is intelligible and that which is recalcitrantly unintelligible in the political world. Well, we need something more than ourselves waxing philosophical. So as always, we end with the gospel for today, which is from Matthew. Jesus said to his disciples, "Beware of false prophets who come to you in sheep's clothing, but underneath are ravenous wolves. By their fruits you will know them. Do people pick grapes from thorn bushes or figs from thistles? Just so. Every good tree bears good fruit, and a rotten tree bears bad fruit. A good tree cannot bear bad fruit, nor can a rotten tree bear good fruit. Every tree that does not bear good fruit will be cut down and thrown into the fire. So by their fruits you will know them. Come, Lord Jesus, come."
Thank you. Thank you, Paul. Excellent. Excellent.
Well, thank you very much. I appreciate very much being able to talk with you.
And for the
so much
Spanish speaking here, ya los vamos todos juntos.
Okay.
Godspeed. Take care.
Godspeed, everyone. Thank
Okay,
you, Paul.
bye-bye.
Thank you.